So a few days ago we did a Midland 3001, and for the same end user we've got a rather repainted Midland 2001. In the back catalogue we've got the RAL number for the proper case colour for those interested. You probably have to trawl through though. So the first thing I notice is that this connector is broken. What we'll do, got a frog in the throat, we'll remake this power lead because it's no good like that without a fuse holder. So that's something I'll pass on to Mr. Chippy, and in the meantime we'll use one of the ones which we make. Basically we'll be using his moulding on with new pins and lead. Makes it a bit cheaper, makes it a lot cheaper. So we've got a mic with this, and we'll test that later on. Now he specifically said don't do anything with mics. It does rattle, so it needs some kind of packing in there. So we'll test it. So come on, we'll test it as it is before opening it up. So I'll connect that to the test equipment and that to extension speaker. No, that wants to be in PA speaker, and then the test equipment speaker input to the external speaker. We'll switch to PA. Testing 1 2, and I've still got them the wrong way around. It's difficult to see the stampings after 40 years. Testing 1 2, testing 1 2, and you actually have control over the volume on this version. This is the December 81, so it's probably the one with the non-adjustable meter. So right now we can tick off the PA function, the sockets, and the meter lamp. So we're on channel 20. Switch picture in picture on. It's on. We're on the 3 watt scale. The radio's doing, oh dear, it's not doing much at all, is it? It's doing 1.5 watts, is it? No, that's 1 watt. It's doing 500 milliwatts. It's not even doing that, it's doing 200 milliwatts. Channel 1, 150 milliwatts. Channel 40, 220 milliwatts. Our pen's expired. Get another pen. Right, it's got another pen. For what it's worth, let's have a look at what the deviation is on this test set. Now we were on CPT yesterday, so I'll have to retune it. Wallow. Wallow. According to this, it's off the scale, it's beyond 5 kilohertz. Frequency. So we're looking for 2779125. 27. Do you know it says off frequency is the really last one from him? Just hope this one will shift. So we'll put that low frequency in the signal generator to test the receive, so that the receive is the same as the transmit. 79063. Right. Signal generator on. S9, and the meter says a generous it is 35 microvolts, so it's more sensitive than it ought to be, but it's probably like that. I put it in the wrong box, haven't I? Let's see what the meter says about transmit. It says it's about 500 milliwatts. Switches work. Right. See what the sensitivity is like. Sounds a bit IF-y again. Cyanide meter on. Let's put it onto the camera and move it. So anything under 1 microvolt is okay, and we are at 0.88. So I could say I've seen better, but we'll see what happens. 0.79, and for 20 it's just not quite on the 1. It's 1.15. Squelch. Put it to full on the radio, and on the signal generator let's go to the attenuator so you can see what I'm doing. I want it to open at 100 microvolts, 3, 10, 30, 100. It never opens. Right, so squelch threshold. We'll put the signal generator to standby, turn it down on the radio till we get threshold. Switch the signal generator back on. It's 1 microvolt. So that's where we are. So transmitting at less than half a watt. That could just be alignment. It could have a fault. Somebody's gone to all the trouble to paint that, and that looks like it's got scratched in transit. I think first of all, when we just on Solar's speaker, we'll see whether we can get it onto frequency. We're in this dilemma that new cheap crystals never seem to work properly, don't go onto frequency, and most of the scrap AM sets, the crystals are knackered. So, you know, this is the snag. So first thing we're going to do, if I need to get this over 79,100, I'd like it to be where it should be, 125, but if I get over 100 we're okay. Right. Phew. Spot on. It's done it. Glad about that. It's just funny, it was exactly the same off frequency as his other one. But at least this one's gone. So we're not touching the VCO, you need to put extra parts on, as I've said a million times. And it works on channel 140, so it hasn't got a VCO issue. But it's certainly got a transmitter issue, hasn't it? Doing 300 milliwatts. Can't see any sharpness there. Before I try, I'll try and do a tune, and then we'll see whether there's dry joints. There's always that possibility. So we're on the lower scale. We're doing 100. It's doing 250 milliwatts at the moment. That's the peak of the, and that's the peak there. And that's the peak there. Wow, we're at 650 milliwatts. It's not going beyond 700 milliwatts. It's showing 565 milliamps. I will just make a note of that. I think we'll start by looking for dry joints. Oh dear, we've got another snag. It's got the wrong audio chip in it. There's the heatsink insulator. Somebody's put the wrong chip in. Or mounted it wrongly. You can't have that without a heatsink. So that's a problem. So I've got enough, hopefully, scrap sets to recover the right hardware, but whether we've got the IC, it's a Kia 7205, not a TA 7205, and there's a difference in physical size. Now the American AM sets, which is what they do kick around in this country, the illegal sets have the TA 7205 in them. Oh, this is not good. Just going to check the voltage on the voltage regulator, because that's had work round it too. Is it case negative? I'm the wrong way around anyway. Let's go to the negative on the power lead. Might help if I was on 13.8 volts. So it's staying stable at that. So is that supposed to be the protection diode? I'm just going to try and retune it now. Actually, it was totally my mistake that it's on the wrong power supply voltage, but I don't think it's going to make much difference. We have got 1 watt. I'm just going to go through it all again. This coil's in the wrong position, so there's something iffy around here. So we're now at 1.2 watts. It generously says 2.5 on the meter. So if I show you a typical set with this chassis, I'm sure we can find a scrapper, just to show you where the coil normally is. Yeah, well, coil's missing on that remains of one, but we have got the audio IC. I think maybe the rise audio IC, it may be mounted too low down, so you can't have it without the heatsink. I'll pause the video to see if we can find the chassis. Right, here's a Cobra version. And you can see, well, hopefully we can see how far down that is. It's not very far down at all. It's the equivalent, if I compare, of being about there. So it's in this tuned circuit that the problem must be. So I'll have a look at the circuit diagram and see what would cause the power being developed around here to be robbed, or the tuning of this to be affected. And this again, this hasn't got the IC. That's been had. We've had some of these capacitors go down before now. You got these, I expect the silver mica between one section and another, as the RF's generated and goes through its various stages of amplification. You've got these capacitors, and I've had one of these sets where every single one of them has been leaky. Now, I don't think every single one of these is leaky, but I think that's what we're going to be looking at. I'll get the circuit diagrams out. I think what we're going to do here, we've got the customer sent something for spares, a Maxcom 4E, and this one transmits. It's doing about 3 watts. This is the one we pinched the crystal out of to sort out the frequency problem with his other set, so he wasn't having to pay for parts. So I think the thing to do, I think we're going to start by taking the output transistor out of here, because of course it can be the transmitter output transistor that causes a problem like this. So I think that's the first place to start, and I may be able to find another heatsink mounting kit without taking it out of this set. We can still restore this by putting back bits that I buy in. The other thing is I've put a crystal in here which is off frequency, it's out of spec, but at least it tells us that the radio is kind of working or not. So I think that's the thing to do. Not sure what's supposed to be wrong with this. Not got the meter in it, but let's put it on, put channel 20 in the signal generator. You can see it's receiving because the meter's saying so. Right. Anyway, he sent that for spares, so that's what we'll do, and we'll put he's previously issued me with one of these connectors, so we'll give him one of those. So hopefully we won't have to ask him to pay anything towards parts. Right, I'll get on with this and I'll take this output transistor out and swap it. Right, we'll get this transistor tester onto these. So the one that's come out of the Maxcom 4E, and if you look, they're both kind of the same. It's not just a matter that they've got a different batch code on, but they're the same device. They're not like a different make. I would have said, however, that the one out of the Midland has been replaced. This definitely hadn't. So we've got a gain of 74, which is about what we're going to expect. I could show you the data sheet. So see what the gain is on this one. So I'm doing it this way because it's easier than changing capacitors. Gain is 3. Okay, I think we've got to the root of the problem. So what we're going to do, I'm going to get the thermal heat compound. And make sure we've got new thermal heat compound on it. Right, so I've done that, and it's now a matter of connecting it back up to the power supply. And the test equipment. So I would think that that's going to be the fault. bound to prove me wrong, isn't it? Right, it's going to transmit. Wow, straight away. So we've now got 3.6 watts. So we'll now do a retune. We'll take it from here because those are going to not be affected. So that's definitely at the peak. Yeah, that one has affected. We're about 3.7, 3.8. The manufacturer says 3.8 watts on these, but we're going to go for 4 if we can do it. So that's 4.05. And you're supposed to set the power with this one. Let's see what it goes about. It goes about 4.2. So it's quite a good example that. Right, so pop it on channel 40. Well, it's gone to 1. Alright, so it's fractionally over the 4 on 1. And it's fractionally under the 4 on 40. So I'll tell you what we'll do. Of course, this now is a bit warm. We'll just take it marginally over. It's like 4.02 there. So now we'll see what it is on the other channels. Channel 1 is now about 4.04. Channel 40, it is like 3.99. So this is when warm, remember. When I write these down, this is when the radio is warm. So when it's cold, it could be very slightly over, but that's within measuring allowances. So 4.02, 4.04, 3.99. Low power. Oh, doesn't have it, does it? Right, current consumption, channel 20 is 1.065 amps. So I don't often get output transistors that do that. Perhaps it's been on a bad SPR or something like that. I mean, the set's clearly been reverse polarity at some time in its life, and that might have taken years to knacker up. I think that's come out of another set, although it's the original type. I think that's been recovered out of another Maxon set rather than having always lived in this set. So that's got the transmitter into operational condition. I've only got 15 minutes and would want to do an on-the-air test, so see if we can get this audio IC out and a mounting kit found on a scrap set. And unfortunately, as I was saying earlier, it's not like the AM sets have got the mounting hardware. What I'll probably do is recover it out of this Maxcom 4E for now, just to get the mounting kit. We'll do that, and then it speeds this along. I'm sure that I can find a scrap set with this hardware arrangement, because the audio IC is working, but it's not soldered in the correct position. Now, of course, why is that? It could be it's been recovered out of another set, and the leads weren't long enough. So we'll just get this out. So it's an M3 screw, then you've got an insulator, and then you've got the M3 nut, you've got the washer, and then you've got a square washer. So you've got, you see all these components that you've got. I'll just take it from there. So the tab's insulated, and of course the insulation, can't speak, mica. So you've got all those parts. Luckily the mica was inside this set. So we borrowed that. Hopefully we don't have to take the chip out. So what we'll now do is we've got to unsolder, because you can see the holes don't line up. That's got to be central. So it's been soldered in too low down. Right, let's get the power off. I'll get on soldering this. I can see some of the tracks are damaged. I don't know what's going to happen. Okay, so back into record. Going back to PA, I've managed to remount it. Tell you what to. So I'm going to clean up around there, but it's now mounted properly on its heatsink. It's the same chip. I've been able to bend the legs such that we've just about got enough to cover. I think it's come out of a similar chassis set, so it should have had the legs that reached, and it did. So I'll put the thermal heat compound again away. Pinched off Mr. Chippy's bench, don't tell him. Right, I've got to get on with the on-the-air test, to be honest, because so I need to just, otherwise it's going to end up delaying it by 24 hours, which I don't really want to do. So we've remounted that, so hopefully it'll just tune up now. Let's go to CB. Woo. And we'll get on with the tune-up. So check that we're all on frequency on the radio. I'll just go back because things may have changed. Soldering crystals. No, we didn't solder the crystal on this, did we? It was the other. So 2779125. It's a bit high now. Just pop that down. Do as nicely. Right, signal generator on the same frequency. Let's pop that down. There we go. Let's look at the oscilloscope. So, as usual on the Maxons, the detector, just make sure we've got 100 microvolts on. The detector can often go out of kilter. But not on this set, it's spot on. I'm thinking these IFs are out because it doesn't sound right. So we're going to do this a funny way around. So we'll put 12 dB on the synod meter. Let's go over to the synod meter. And I'm just going to do these IFs roughly first. Yeah, that one was miles out. Drop the signal and look at the other one. No, it wasn't that one, it was that one. Right, well now we'll do the front end. That wasn't far out. That was, though. Back to this one. Bigger signal for that one. There we go, I think we've cracked it. Okay. So, let's get a new set of readings. So, it's now 0. I think one of these sets we touch. It's 0.6. For 10 dB, it's 0.55. For 20 dB, it's 0.95. Okay, so how's our squelch? So I'll put the attenuator up on the screen. 3, 10, 30, 100. Well, let's adjust the squelch preset till it just comes in. That's the air conditioning come on. Okay, that's 100 microvolts, and at the other end, sensitivity is now 0.5 for the squelch. So that's 100 microvolts and 0.5 microvolts. That leaves the... I'll just do on transmit, we'll just get that meter to... tell you what, I'll put the bottom lid on. No, I won't. It's reading over 5, so adjust the preset. So we get 4. Low power. Oh, I keep saying that it doesn't have it. Deviation needs doing, and the S meter doesn't have it. So we're all done apart from the deviation. So we'll plug into the test set behind me, which has been sat there warming up nicely for the last hour. No wonder the air conditioning keeps coming on. Ugh. Right, I'll tell you what it says. What? Yeah, I won't even bother telling you what it says. It's beyond 5. But that really compensates for it not transmitting. There we go. 2.5 peak. Let's see what it says on the Marconi test set, whether it's in a lying mood. I didn't believe it when I checked this initially because it was full scale deflection. Right, let's go on to that meter just for giggles. Wallow. Oh, it says it's about 2.6, so I think it's correct today. So that's that done. Corrected that. Just see what the S meter does read now that the receiver's realigned. It's worse. 17 microvolts. Because I fixed the receiver problem with the alignment, the S meter is even more generous. Hello folks, just here with the camcorder inserting this bit. Just editing the video. Look on this board, I can see we've got a preset, and it's obviously the meter preset. So on the early version you don't have a meter preset, which is what I thought this one was, because otherwise it's down there. So we may as well align this because it was grossly out. So with the camcorder, I thought we'll do this, then at least the customer can see we have. I'll put S9 on the signal generator. And there we have it. So we've done the on-the-air test already, because there were two things to do. There was the power lead to repair the socket to do and the protection diode to do. So the power lead's been done, but not the protection diode. I'll do that first thing tomorrow morning, then the radio can go back to the customer. So right, we'll go back to the main part of the video. Just thought I'd add that and correct it. So not really that easy a fix, and I'm glad that it was just the output transistor. But trying to get genuine ones new is not easy. So that was the thing to do. He sent a set in, and he's not going to have to pay for any parts we've used on this set. We may have to ask him something towards some power lead, but it won't be a lot. In fact, probably the biggest item is the inline fuse holder. I think the 179 these days. We only use the RS ones, these. I know there's some El Cheapo ones for about 25p, but I don't trust them. Right. We'll put that together without the screws. Make sure it works into its own. And on this one, the TX light works without any intervention, which is always something, isn't it? Yeah, that sounds fine. Right, we'll put it on the aerial. One on a Roger. One on a Roger. Okay, nobody for a Roger. That's not unusual, is it? But I thought the Nottingham Burner Brigade made me out there swearing and cursing and playing music, but it seems not. It is Sunday evening, just approaching 7 o'clock. I think is there a religious programme on television at this time? Perhaps you're all watching that. So thank you for watching. Nearly finishing the Midland 2001 for the same customer as the 3001 we did. And there we go.